We finished the last video by asking the question of what the bizarre reality of wave-particle duality at the subatomic scale and the resulting implication of the Heisenberg uncertainty principle means metaphysically for the nature of reality. The major way to understand this today is the Copenhagen interpretation, which was developed by Niels Bohr and others in 1928. Remember, Niels Bohr was the Danish physicist who first applied quantum theory to the hydrogen atom and discovered energy levels and explained spectral lines. So he went on working with quantum theory and tried to figure out what it all meant. I want to stress that at this point, we've moved beyond physics. We're into metaphysics. We're into the way we understand empirical truths, what they mean for us on a deeper scale. This is not anything that's scientifically proven or scientifically provable. Nevertheless, the Copenhagen interpretation, which was developed in Copenhagen, the capital of Denmark, is the most common understanding of what quantum theory means for reality, how we put together the waves and the particles that seem to coexist, but in our understanding really can't or shouldn't. There are a number of major ideas to the Copenhagen interpretation. The first of them is what's called superpositioning. What this says is that at the subatomic level, the reality of any particle is actually a state of superpositioning, which means that every possible quantum state that the electron could exist in, that we could observe it in, actually exists at the same time within that delocalized wave function. So every possibility is equally real at this point, and therefore we need to describe the electron in this superposition state by an infinite set of quantum numbers rather than by only 4 quantum numbers. Okay? So in this sense, the particle is everywhere, but it's nowhere definite because it exists as this superpositioned reality of infinite possibilities. Well, how do we go from those infinite possibilities to one possibility? That's a second big idea of the Copenhagen interpretation, and that is that when a particle is observed, when we try to learn something about it and we cause it to interact with energy, then it collapses from this state of an infinite number of realities down into a single reality, a particle in a single place, described by only 4 quantum numbers. The third idea that we'll mention about Copenhagen interpretation is that which state it collapses down into, which one state out of this infinite number of states that existed when the particle was superpositioned, is not governed by any law. It's not that we don't know the laws that govern the collapse. There is no law. It is a matter of chance. All we can describe it as is a statistical probability, never a certainty. This is the idea of quantum indeterminism. And it's very different from what science has traditionally said, where you can discover a law that if this happens, then you know that that will happen. Quantum indeterminacy says that there's no way to ever know for sure what state the electron will collapse into from its superposition state of infinite realities. So to give you an analogy, imagine this is our infinite set of quantum numbers, and obviously it's not infinite, but this is the electron in its superposition state. It could collapse into any collection of 4 quantum numbers that will give it a particular quantum state, but quantum indeterminism tells us there's no way to predict ahead of time which 4 sets of quantum numbers it will collapse into. So this reality could collapse down into this reality, or it could collapse to this reality, or it could collapse to this reality or any other number, but it goes from an infinite number of real possibilities to only one real reality. Another analogy, which I like better, is imagine that you have your kitchen cupboard and you stock it with every kind of cereal that you can find. But with the door shut, you can't observe those breakfast cereals, so they're all in there. They all exist inside your kitchen cupboard. But amazingly, when you open up the cupboard doors to observe the cereals, you find that there's only one cereal in there. All those boxes of cereal that were really there have become only one box of cereal, and in this case it's Honey Nut Cheerios. You had no idea it was going to be Honey Nut Cheerios. Then you close the kitchen cupboard doors and you open them again, and now instead of all of the cereal being there or the Honey Nut Cheerios being there, now the reality is Fruit Loops. Close it again, and the next time it's Corn Flakes. Close it again, and the next time it's Oatmeal Crisp. And you have no idea. You will never see all of the cereals. You will always see only one of the cereals. Which one is a matter of chance? That's the idea of superpositioning. All of the cereals existing is the superpositioning. One cereal appearing is the collapse of the wave function from many, many possibilities to one reality, and the fact that you can't tell which cereal it's going to be illustrates the idea of quantum indeterminism. Now this leaves us with a really, really big problem, this Copenhagen interpretation, a really big problem that seems to run absolutely contrary to all of what science was based on beforehand. And that's this problem. Science, from the time of shall we say, Kepler, around 1600, up to Planck in 1900, for 300 years, the big idea of science was that we can figure out how the universe works and therefore be able to predict it if we just understand the laws. But the Copenhagen interpretation is saying something completely different, that the wave functions can collapse in virtually infinite ways. So why then does the universe look predictable to us when at the quantum scale, at the very heart of it, it's governed by chance? We'll answer that question, or at least we'll try, according to the Copenhagen interpretation, in the next video.